In this video, we'll look at how cloud providers can deliver multi-tenant serverless inferencing for enterprises and retail end users. Let's start with the conceptual view. So the way this is set up using Rafay is you can have a unified inference endpoint behind which you can have X number of models. In this visual, you have this inference endpoint serving Llama, Qwen, and DeepSeek models. And these inference endpoints can be used by both individual retail internet users and users inside specific customers such as Coke and Pepsi. And this whole thing can be delivered using Rafay's GPU PaaS, and all the token usage and cost metrics, etc. are stored, and they can be retrieved and used for billing purposes by the cloud provider's billing system. So let's start with the end user experience. The end user, what do they have to do? There are essentially only three simple steps for end users. They log in, they generate an API key for authenticated access, and they use the inference endpoint programmatically. That's it. Now let's look at a demonstration of this. Now let's log in as an end user. So the end user logs in into their end user portal, and when they click on GenAI, they are presented with a list of models that the cloud provider has made available to them. Let's go look at the first one, which is Llama 318B instruct, and I'll go into that, and it basically tells me here are the ways by which I can use it. But before I do that, as you can see here, I need my API key. And every access is going to be authenticated. So let's go do that. Let's go generate an API key. I'm going to create a new API key called testing and create it. And this particular key is only available to me, shown to me once, so I just have to make sure I save it. So what I'm going to do is I'm going to export this API key to my environment so I can use it now. Now when I go to the models, and let's say I want to try out this model and go to this thing, and I click on API usage, it presents me with a list of instructions that I can just copy this command and run it. And let me just copy that and run it. And this should take a second for it to execute and get a response back. And as you can see here, it gave me a response, which is under the word content. So it gave me a response. Then it basically says the model that was used was Llama 3B instruct. And then, as you can see, it consumed a total of around 315 tokens. Now, as an end user, at this point of time, I want to understand how much of what am I using and what's it costing me. Right? We saw the details presented, but the Rafay platform also tracks usage. So if you go into usage, as you can see here, it's already captured some details. And we notice here just a few seconds ago, I had made a few calls where it's showing me details for what was presented. Remember, I had used about 315 tokens, and as you can see here, it's reporting 315 tokens. Now, what did the cloud provider have to do to deliver this kind of an experience for users? Let's look at that. The typical steps for cloud providers are there's a one-time setup where they'll create the compute or point the Rafay platform to their GPU accelerated compute. They will create a storage namespace with local storage where they can store the models so they can be pulled and retrieved dynamically when required for auto scaling. And then they'll create an inference endpoint and provide credentials so that it can be an HTTPS endpoint. This is a one-time setup. And per model, they have to essentially do two simple steps. They will have to upload the model and its weights to the storage namespace that they created above, and then they'll deploy the model where they'll configure it with appropriate details so that it can be delivered as a serverless inference endpoint. And that's it. Very simple workflows to deliver this as a service. Now let's look at a demo of this in action. So I'm logged into the cloud provider's operations console in Rafay. And as you can see here, there's a bunch of tenants called organizations in the platform. I have two tenants, two orgs, one called Pepsi and the other called Coke. So as a CSP admin, you click on GenAI, and then the first thing you got to do is we will create a storage namespace. And the reason for that is the foundation models like Llama, etc., them and their weights, they can be pretty enormous. So as a user, all you have to do is create a new storage namespace, provide it a name, and select the storage option. As you can see, you can choose between a variety of options, things like Ceph and Veka for high-speed storage. And this allows you to store the models and the weights and every associated data with the particular models in storage that is right next door to our inference endpoint. The next thing is we need to give the GenAI platform access to compute. Let's go look at one example that's been pre-set up. And as you can see here, this one needs access to a bare metal server. So what happens here is you point the platform to the MAC address of a bare metal server, and Rafay will automatically create virtual machines on the bare metal server and deploy Kubernetes on them and ensure it's attached to the Kubernetes cluster underneath and deploy the inference endpoint service into that particular worker node. And it does this in an automatic manner so that new VMs with Kubernetes worker nodes, etc., can auto scale up and down based on demand and usage of the platform. So once the compute has been set up and you have a compute, the next thing is an endpoint. So we set this up here, and let's look at this example that we have set up. I just had to give it a name and the FQDN where this will be available, and then I point it to the compute. So basically, when requests come into this particular FQDN, they'll be serviced by the inference endpoint service that is deployed on this on the compute that was made available to the application. The next thing is models, and here you can have as many models as you want. Now in this particular examples, we have a few, some with Llama, some with Qwen, some with DeepSeek, and let's go look at one of them. Let's go look at an example of what we have here. Again, very simple workflow. You give it a name, you choose the model from the list of models that were created. So here we selected Llama 3.1 8B instruct. Then you specify the endpoint that you had created in the prior step. And once that is there, you have to now tell the system during deployment how you would like to accelerate it. And in this particular example, we have chosen an L40 with about 48 gig of GPU memory. You can also have others like an H100, etc. Then you decide how you want to quantize the LLM for optimized inferencing, and then how you wish to scale. So I could change this from 1 to 6 to 5, whatever number I want, and then I specify how I want to charge for it. Now the last step in this process is, at this point of time, although this model has been deployed, it's not available to all users yet, all the retail users or the enterprises yet. So The way to do that is a very simple one-click process where you click on Manage Sharing, and then you can choose all organizations, which means this will be available to all customers managed by the cloud service provider, or they can choose specific organizations and say that make this model serverless inference endpoint available only to, in this example, Coke. What this essentially means is at this point, this equates to a dedicated serverless inference endpoint, which all users under Coke can access, but users from Pepsi cannot access.